Are we truly the only living beings in this vast cosmos? When we gaze at the observable universe, which spans roughly 90 billion light years in diameter, we are confronted with mind-boggling numbers. There exist at least 100 billion galaxies, and each of these may contain anywhere from 100 to 1,000 billion stars. Recent astronomical surveys have confirmed that planets are not rare at all. Indeed, there may be trillions of planets that orbit stars in habitable zones. In other words, there should be countless opportunities for life to arise and flourish. So, why is it that, despite the overwhelming numbers, the skies remain eerily silent? Where are all the advanced civilizations and their spaceships? Let's pause for a moment and consider the scale of the challenge. Even if extraterrestrial civilizations do exist in galaxies beyond our own, the expansion of the universe means that everything outside our immediate cosmic neighborhood, the so-called local group, lies far beyond our reach. Due to cosmic expansion, the distances between galaxies are growing. And even if we were to develop near-light-speed spacecraft, it would take billions of years to traverse these enormous voids. As a result, we must narrow our focus to the Milky Way, our home galaxy. Within the Milky Way, there are up to 400 billion stars, a number so vast that counting each one at the rate of 1 per second would require 100 lifetimes. Among these, roughly 20 billion are sun-like stars. Current estimates suggest that about 1/5 of these stars host an Earth-sized planet in their habitable zone, a region where conditions may be just right for life. Even if a mere 0.1% of these planets nurture life, that would still yield around 1 million life-bearing worlds in our galaxy alone. Yet, despite this potential bounty, Earth remains the only known cradle of life. The Milky Way itself is approximately 13 billion years old. In its early days, the galaxy was a hostile environment, with rampant supernova and other violent events making it unsuitable for life. It wasn't until 1 to 2 billion years after its formation that the first stable habitable planets emerged. Our own planet, at 4 billion years old, has enjoyed a relatively quiet period in cosmic terms. Even so, given the vast time span and the countless opportunities for life to develop elsewhere, why have we not detected a single spacefaring super-civilization? One popular framework for discussing these issues is to consider the different types of civilizations based on their energy consumption and technological prowess. A Type 1 civilization harnesses all of the energy available on its home planet. Humanity, by current estimates, is at about 0.73 on this scale, and might reach full Type 1 status within the next few hundred years. A Type 2 civilization would be capable of capturing all the energy of its home star. Think of enormous engineering projects like a Dyson sphere, an enormous structure or swarm of satellites that fully encloses a star to collect its energy. Then there is the Type 3 civilization, a society so advanced that it can harness the energy of an entire galaxy. Such a civilization would seem godlike to us, and if even one existed in our galaxy, we might expect to see unmistakable signs of its presence. A curious thought experiment follows. If a civilization were to construct generation ships capable of sustaining life for around 1,000 years, it would theoretically take only about 2 million years to colonize the entire Milky Way, a blink of an eye compared to the galaxy's 13 billion year lifespan. Given that there are potentially millions or even billions of planets that could harbor life, and considering that some life forms elsewhere might have had much more time to develop, the question is, why do we not see any evidence of these civilizations? This dilemma is known as the Fermi paradox. So what are the possibilities? One idea is that there might be one or more filters, critical barriers that prevent life from progressing to a stage where it can spread through the stars. These filters can be thought of as major evolutionary hurdles. Some may lie behind us, difficult challenges that life on Earth has fortunately overcome, while others might lie ahead, waiting to thwart our future progress. For example, the emergence of life from non-living matter, abiogenesis, could be an exceedingly rare event. Alternatively, while simple life might be common, The leap from single-celled organisms to complex multicellular life might be so improbable that even with billions of habitable planets, only a few manage to evolve beyond the simplest forms. Another possibility is that once life reaches a certain level of technological sophistication, it becomes prone to self-destruction. Advanced technology, whether through nuclear weapons, runaway artificial intelligence, or ecological collapse, could cause civilizations to annihilate themselves before they ever manage to colonize the stars. Yet another speculation is that there might exist a super-advanced Type 3 civilization that patrols the galaxy, deliberately eliminating emerging civilizations to maintain some form of cosmic order. Although this sounds like the stuff of science fiction, it remains one of many hypotheses designed to explain the cosmic silence